Hi, in this video I'm going to show you how to run a 4-port through reflect transmission calibration for a quasi-optical setup. So here we have one horn plus the lens. The lens converts the spherical wave from or Gaussian beam from the horn to a plane wave at the center, and then on the other side we have exactly the same setup that would receive the transmitted plane wave from the sample. Now there is no sample here, but we're going to, after calibration, we're going to put the sample here. So let's start to do that. So as you can see, these horns are have dual linear polarizations with the help of the OMT here. And on the other side we have the same thing. So we want to run this calibration for 4 ports that are connected to the receiving horn, and then to the 2 horns that are connected to the transmitting horns. Okay, so first let's just start preset. So everything goes to default setting. Then we're going to set our frequency range, so press frequency. We are going to look at the start. These horns for X band, I'm going to push it to 7 gigahertz, see if this would help. So I'm pressing 7 gigahertz. Then for the stop, I'll put 13 gigahertz. So here I have 7 gigahertz to 13 gigahertz. Okay, so now we are going to choose our calibration. So start cal wizard. Now this comes up. So here, since I'm going to run a 4-port calibration that I'd like to define, I'm going to go with a smart cal here. So let's go next. Oops, next. Here, this is an 8-port PNA. The 4 ports that I'm using are port 1, 3, 2, 4. So I'm checking 1, 2, 3, 4 here, then pressing next. Now here we have to define the waveguides that are connected to these ports. So as I said, these horns are X band, so I'm choosing the DUT connectors here, X band, for all of them. Oops, change this one, X band. Okay, then we're going to choose modify cal, because you'll see in a second that we need to define what are the cases we are measuring here. So it says through is port 1 to 2, 1 to 3, 1 to 4. So in this case, because we have 4 ports and 2 polarizations, I would like to calculate the transmission from the horizontal port to the horizontal port, the vertical port to the vertical port, and then the horizontal port to the vertical point. Okay, so based on that and based on the configurations of my ports, that would be port 1 to 2 for horizontal to horizontal, port 1 to 4 for horizontal to vertical. Port 1 is actually horizontal, port 4 is vertical. So this is horizontal to vertical. And now for vertical to vertical, I'm going to choose port 3 to 4. This is based on your configuration. You have to change this. But the 3 throughs that you're going to have should include horizontal to horizontal, vertical to vertical, vertical to horizontal from the 2 sides. Then we press next. So here it says port 1 short. Port 1 short in a TRL calibration is basically when you have completely reflection on the 2 sides. So here I have a complete copper plate here. I'm going to put this one here, just rotating these. So you have to make sure that this copper plate is right in the middle between the 2. So let's assume that's in the middle. There is something going on. Okay, yes, okay, right in the middle. Now we can press measure, try to stay away from the setup. Then again press measure for port 2 because we still have the copper plate in the middle. Now it says port 1 to 2. So we are going to remove this one because port 1 and port 2 are on the two sides. We are going to measure the through for these cases. So nothing in there. We are pressing measure again. Now it says port 1 to 2, 1/4 of the line. Here, the central frequency in X band is 10 gigahertz. That means that lambda is about 30 millimeter, right? And 1/4 of the line means here lambda. 1/4 of lambda would be 7.5 millimeter. So here we have an actuator. I'm going to move this setup, the receiving side only, all together with the lens and the horn, 7.5 millimeter. So we're going to go from 5 to 12.5. Okay, so this is it. Now you can manually take this back. Now we are going to measure this. Okay, we have to bring the setup back to its original, so we're going to go to 5 again. Now that we measured our line, this is done. So we're going to go back here, 0.5. This is only you need to move the setup on one side. Now it asks us to short port 4. So we're going to put our cover plate back here. Okay. Now we're going to measure the reflection. Okay. Again, what point 1 to 0.4 is a cross polarization measurement. It's going to be very close to noise level. So what we're going to do is rotate one of the horns so that we have a meaningful measurement from point 1 to 4. So this is our horn. I'm going to rotate it 90 degrees so that port 1 to 4 is not going to be in the noise level. So just going to put you here. Okay. So the cable is behind the horn, so everything is fine. So we're going to measure this. Now it asks for port 1 to 4, lambda over 4. So again, in the same state that the horn remains, we're going to move this again 7.5 millimeter. Okay, we're moving this, measuring again. Okay, so we have to put the setup back exactly where it was. So we're going to go to 5 again. Put the horn back because now it's going to ask us for vertical to vertical. So we have to put the horn back in the previous state. So here, I'm going to rotate the horn back to its original. To make sure that the cables are not moving too much here. Okay. Now it asks us to short port 3, as you can see here. So the VNA or the PNA guides you through what you're measuring here, so no guessing required actually. So let's go back. I put the copper plate here because I have to short port 3, measure. Port 3 to 4 is our vertical to vertical, so no need to rotate the horns. We are measuring through. So we're removing the copper and pressing measure. Now 1's lambda over 4. So again, because the two are in the same polarizations, no need to rotate the horns. So here I'm going to go back to 12.5. Move this back. Measuring this. Okay, now we can save our setup. So here I have a bunch of, so I'm going to measure this. As you can see, I've been repeating these measurements for accurate results. So today is 25th. So 25th, save this. Okay. Now, if we want to see how successful our measurement was, what we can do is put the plate back, copper plate back, right? We're putting this back. Port 2 and 4 on that side. I'm going to only look at, we can put here measure S22. I want to see how S22 looks like. So you can see this is between 7 to 8 gigahertz because this is actually out of my X band. So the horns or the OMTs are not working properly. The same thing here, 12 to 13. So the good use here is between 8 to 12. So what we can do to remove all of these multiple reflections, we can go to transform. Look at the signal. If your VNA has a time domain functionality, then you can look at the signal in time domain. So you can see here I have a multiple reflection. I'm going to remove this one. So I'm going to go to analysis here, gating, gate stored. It's about -1 nanosecond. So I'm going to enter that. And then for gate stop, 1 nanosecond. So, and then press gating on. So as you can see now, it removes the multiple reflections that I had. And we're going to go back, transform off. So you can see we have a smoother results. Now let's look at, so about 0.90. So this ideally this should be exactly 0 dB, but obviously because my setup is not covered by absorbers, I don't have very good results here. What we can do, we can measure. Well, you know what? I'm gonna fix this on my own. So, but this is 4-port calibration. So what you want to do, let's look at the format here. So as you can see, this phase has to be completely constant because by calibration, you're removing every effective, basically, air that is between the two, and then also the copper and everything else. You're referencing everything to copper and air between the two horns. So yeah, you have to basically keep repeating this till you get very good results in your calibration. Then you put your real sample. I hope this video was helpful. Thank you.